Alright guys, welcome from Mr. Neubauer's house. We're going to be continuing on to section 11.4 on adding and subtracting rational expressions. I thought I'd embed the webcam just so I could see you guys all, or at least you guys could see me, and hope everything's going well for you guys out there in COVID land. So let's get started with today's lesson, and we're just expanding on what we talked about yesterday. Or in the last lesson, I should say, adding and subtracting rational expressions. We're going to warm up with something similar. So let's get going. First thing, find the difference between these crazy looking expressions here. Now, again, from yesterday, what we talked about is if denominators are the same, we can simply add or subtract the numerators. So let's try that. First off, add a negative. And by the way, if you guys want to pause and try this on your own and then just check the answer, you can definitely do that. But I'm just going to get going with it because you guys can control that. 9n plus a negative 3n is going to get us positive 6n. Negative 3 plus negative 5 is going to get us a minus 8. And this is all over 10n minus 4. Now, if you guys think back, right, we always ask ourselves, is this simplified? Is this my answer? Well, if you look at 6n and 8, both of those are divisible by 2, so we can write this in a factored form. 10n and 4 are also divisible by 2. We can also write that in a factored form. So we're going to try and do that if possible. This is equivalent to 2 multiplied by the expression 3n minus 4. And this bottom part of this is 2 multiplied by the expression 5n minus 2. And what you guys can see there is that the 2's can cancel, and that can help us to make an even more simplified answer of 3n minus 4 over 5n minus 2. And since neither of those factored anything other than that, that's our answer. Alright, so that was a little warm-up for you guys, something that should have reviewed from yesterday's content. We'll do maybe one more example problem. Okay, this is another one where we're looking for bases to be the same, and then we're looking, can we factor anything? So we've got 7q minus 3 over q squared minus 4, and then subtracting this expression. Again, anytime we're subtracting, good idea to add the opposite. So we're going to add a negative symbol in there, and we're going to make this a positive 5. Then we go about actually adding our numbers together. We've got 7q plus negative 6q. Well, that's positive 1q. We've got negative 3 plus positive 5. Well, that's plus 2. So q plus 2 is going to be on top. Now on bottom, if you guys look at q squared minus 4, well, that's a perfect square to start with and a perfect square to end with, right? And since there is no middle term, there's a good chance that this is one of those, we called it difference of squares situations. So there's a good chance it factors. We're going to write it out as q plus 2 multiplied by q minus 2, right? Q times q is q squared. The middle terms would cancel if we FOILed this. And the beauty of this expression is the bottom and the top have that q plus 2 that we could cancel off, and we could just leave a number 1 on top of this. So this completed would be 1 over q minus 2 as our answer. Remember that q also cannot be equal to 2. I didn't mention that in the previous example, but q technically cannot be 2 for this to work. Now today we're getting just a little bit more complex with our expressions. That was just a very quick review of yesterday's stuff. But today we're going to work on expressions with different denominators. Right? And you guys have seen this. You guys have done this with just regular fractions. If the denominators are not the same, we have the power to make them the same by multiplying the top and the bottom of the fraction by some number or some expression. So we're going to attempt to do that with this. Now, what I like to do with these is I like to look at the numbers first, the numbers 2 and 6, and think about where they'll match up. And in my mind, 2 and 6 will match up at 6, right? We don't have to, really do anything with that. Next thing we're going to look at are the variables, x squared and x. Where will they match up? Where they would match up at just x squared. So again, I'm going to try and multiply this by something to make it an x squared, and this by something to make this 2 into the number 6. So with this expression, I'm going to multiply by just x, and I'm going to multiply it by x over x. All right? And in this expression, I'm going to multiply the top and the bottom by the number 3. Now, in doing so, I will get a new problem that's equivalent. 3 times 5 is 15. We've got 15 on top of the fraction. 3 times 2x squared is 6x squared. With the second problem, we've got 3 times x. Well, that's 3x. And we've got 6x times x, which is 6x squared. Now the 6x squareds match up. Now we can just look to the top. 15 plus 3x. Well, those aren't like terms, so we just write it out. 15 plus 3x. And on bottom, we've got 6x to the second power. Now, since that top can factor, 15 plus 3x, both of them are divisible by 3. So we're going to, factor this out. This could be written as 3 multiplied by the expression 5 plus x. And this bottom expression of 6x squared, the 6 is divisible by 3. We could, do a little bit more cancellation. If this was to be divided by 3 and this was to be divided by 3, we would just be left with 5 plus x over x to the second power. And actually, as I'm seeing this, I'm looking 3 over 6 would not just get us x to the second, it would actually get us 2x to the second power. And again, this is as long as x is not 0. So the concept is similar, right? Again, we're finding a common denominator and adding. It's just you're doing so with more complicated terms, complicated expressions. Try a couple more here. Now this was kind of just one more example of this, which wasn't the one that I wanted to get to. Where would that one be? There we go. Yeah, we'll maybe get to this one. But we got sum of 3 over 7y to the fourth plus 2 over 3y to the second power. So again, you're kind of looking at the numbers first. 7 and 3. 7 and 3, where will they match up? Well, if you count by 7s, that's 14, 21. Count by 3s, that's 3, 6, 9, 12, 15, and blah, 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 all the way to 21. So I'm thinking that I need my first or my lead coefficient to be 21. Y to the fourth and y to the second power, I think those will match up at y to the fourth power. So I want my least common denominator to be 21 y to the fourth power. Okay, and again, we're adding here. Well, what did we multiply the 7 by to make it a 21? We multiplied it by 3. So this needs to multiply by 3 over 3. What did we multiply the 3 and the y squared by to make it a 21y to the fourth power? We multiplied it by 7, and we multiply it by y squared. And again, you're doing that on top and bottom, otherwise the fraction changes. 7y to the second power. Well, 3 times 3, that gets me 9. So I've got 9 over 21y to the fourth power. 3 times 7 is 21. Y squared times y squared is y to the fourth power. 2 times 7 is 14. Y to the second power. So you've got 14y to the second power. And now again, since our denominators are the same, we just focus in on the numerators. 9 plus 14y squared is going to go on top over that common denominator of 21y to the fourth power. Now it seems like that should simplify, or that should reduce further. But if you think about it, the top can't be factored, right? There's nothing that goes into both 9 and 14 evenly, so nothing's going to divide out of that. The bottom also cannot be factored, so we're done. This is our answer. All right? This is pending that y cannot be equal to 0. Now, problem 4, subtracting expressions with different denominators. Now, if you can see this, alright, now this example here, problem 4, when we're subtracting expressions, a little bit harder to think about, least common denominator between d minus 1 and d plus 2. And it kind of brings you back to a fraction that's similar, like 3 over 4 or 2 over 5, of what exactly the least common denominator would be, because there's really nothing times 4 that gets you 5, at least no integer numbers. And what we would handle or do with a fraction like this is multiply top and bottom by 5, and multiply top and bottom in this by 4. Well, with an example like this, we're going to take top and bottom, 3 and d minus 1, multiplied by d plus 2, and then we'll take 2 and d plus 2 multiplied by d minus 1. So I'll show you exactly what that'll look like. To start out with, we'll take 3 times this opposite d plus 2. And we're going to put d plus 2 in parentheses, and we'll write it twice, because again, this is just a version of the number 1. So 3 over d minus 1 times d plus 2 over d plus 2. Now, on this side, we're taking 2, and then we're taking this opposite part, d minus 1, top and bottom. D minus 1, and then d plus 2 times d minus 1. Again, this is just a version of the number 1. Now, what results from that, and it kind of looks complex, but we get 3 times d, that's 3d. 3 times 2 is plus 6, over the binomials d minus 1, d plus 2, subtracted by, well, 2 times d is 2d, 2 times 1 is minus 2, over the exact same binomial, and I'm actually just going to reorder these, d minus 1 and d plus 2, because these are technically common denominators. Oh, realizing I'm off here, sorry about that. Now, once we get the denominators the same, now we just add the opposite with everything here. So I'm going to turn the negative 2d, or the 2d into a negative and the minus 2 into a positive. 3d plus negative 2d is just the expression d. 6 plus 2 is going to get plus 8. And on bottom we just have d minus 1 and d plus 2. Remember, our last step is always to determine if we can factor and divide anything else out. And with this problem, I don't think that we can do so, because d plus 8 doesn't factor, d minus 1 and d plus 2 are already factored. This is our complete answer. This is our final with a problem such as this. Now you guys can feel free to skip this last example. I just wanted to go through one more with you guys just for clarity. So again, denominators are not the same. We need to make them the same by multiplying this expression by c minus 2, and then this part of the expression by 3c minus 1. So I'll show you what that would look like. C multiplied by c minus 2 over 3c minus 1 multiplied by c minus 2. We're subtracting 4 times this expression, so 4 times 3c minus 1 over c minus 2 times 3c minus 1. On top, I get c times c, which is c to the second power. C times a minus 2 is a minus 2c. We're subtracting 4 times 3c, which might as well just write this out as 12c. 4 times a minus 1 is going to get us minus 4. And on the bottom of this, again, no need of actually foiling this. We're just going to leave it as is. You can see c minus 2 and 3c minus 1. Doesn't matter the order of the terms, so I'm just going to write it out as 3c minus 1 in one binomial times c minus 2 in another. Now on top, there's definitely some simplification that can be done. A minus 2c minus 12c is a minus 14c. So this could be written as c squared minus 14c minus 4 all over 3c minus 1 in parentheses and c minus 2 in parentheses. Now if this expression factors, you should factor it. However, I'm trying to think of things that would multiply to a negative 4 that would add to a negative 14c. And I can't really think of anything. This is as far as this problem goes because of the fact that this does not factor. Okay, does not have any breakdowns that it can get to. So our final answer is shown here. As complicated as that seems, that is our complete answer. We circle it and we say we're good. Alright guys, hope the video is helpful. Enjoy quarantine.